Okay, so let's put some numbers to that, the incline question. This one we have a 12 kilogram block sliding down a plane surface angled at 30 degrees to the horizontal. So we're first going to look at when friction is negligible, and then we'll look at what happens when friction is not negligible. And we start by drawing our forces. So I have force of gravity. That's going to have an x and y component, and we have normal force. So Fn, and this is Fg. And normally the proper way of doing it is putting it at the center of the block. It just gets a little, our students sometimes get a little confused when too many lines are crossing each other. So this is how it should properly be drawn. I just put it right at that surface intersection point to make it a bit clearer though. Okay, so we have Fn and Fg. Again, instead of using our traditional XY axes, we're going to rotate our axes 30 degrees to match the incline. So this thing we know is going to accelerate downwards. So let's look at our forces. We have some of the forces in our x direction. Sometimes we call this x, y, like y prime and x prime. See if we need a different symbol for it. So some of the forces in our x prime direction, that is equal to m ax. And the only force acting in that direction is actually the x component of Fg. So we can call that the applied force, just that Fa. You also need to know that angle theta, that's 30 degrees. So we actually can just go ahead and solve for this very easily. We can say, okay, Fa, this is just equal to, so our mass is 12 kilograms. We're looking for acceleration along that inclined direction. And this is just equal to Fa is opposite theta. So you get Fg sine 30 degrees. That's just equal to mg sine 30 degrees. So what you actually can see too is that when there is no friction, mass is actually just negligible. So mass can be just cancels out. Does not matter. The 12 kilograms cancel out. We see that acceleration is just equal to g sine theta. So you get 9.8 multiplied by sine 30, and we know sine 30 is just half, so we get acceleration is 4.9 meters per second squared. And we are technically done this question. I forgot to actually mention what the question was asking. It's saying, what is A? Okay. How are we going to extend this? Saying what's happening in the y direction? Say sum of the forces in the y direction. Well, we know the acceleration in this case is 0. It's not accelerating up or down that y direction. It's going down the incline. So you say 0 newtons. And we can see that upwards is normal force. But then what does Fn equal to? It's actually just equal to that cosine component of Fg. So it's going to be minus Fg, but cosine theta. So you actually get out Fn is just equal to Fg cos 30 degrees. It's getting 12 kilograms times 9.8 times cos 30. We get a normal force of 101 or 102 newtons. And we don't need that though, because the only times we need normal force is when there's friction.